graphing linear equations. Alright, we've got two vocabulary terms. One that we've been using a lot this last chapter because we've been doing systems of equations, and we've been using linear equations for that. A linear equation is an equation where if you graphed it on a coordinate plane, it would form a straight line, and usually it has an x and a y variable. It doesn't always have to have both, but usually it will. Alright, so one example of a linear equation would be like y equals 2x plus 1. Okay, it's a really standard linear equation. We're going to look at some more linear equations, but this is kind of our basic form. Okay. Now, rate of change. Rate of change is the slope of a line, okay, the slope of a linear equation, and basically it's a fraction with the vertical change, okay, over the horizontal change. This is also known as rise over run. Okay, you might hear me say that a lot. So our rise is going to be our change in y over our change in x. Okay, and keep in mind that's not just the value of y over the value of x. That can be wrong. That can be something different than our rate of change. It's going to be the change from 2 points. And let's look at a little example of what I mean. So if I have a linear equation, okay, say it looks like that, my change, my vertical change, is going to be basically the distance from these 2 points vertically. Right? So if this is at this y value and this is at that y value, it's going to be up 1, 2, 3, 4. We'll say 4. Okay. And then horizontal change is the same thing, looking at it horizontally. So I came up 4, and then I come over 1, 2, 3, 4, 5, 6, 7, 8. We'll say it came over 8. Okay. So it came up 4, and it went over 8. All right. That's my slope. And I can simplify this. I could simplify this to 1 over 2. Okay, but that's going to be my slope. That means that if I am looking at one point to find another point on my graph, I can go up 1 and 2 over to the right. Okay. All right. So our first concept is graphing equations. All right, and here I've got my equation. I can represent an equation in 3 main ways. I can represent it as a linear equation mathematically. I can represent it in a table as the different solutions, so different points on the graph. And I could represent it as a line on a coordinate plane. Okay, so in order to get my line, I generally have to fill out a table. Okay, we'll look at a way later on to be able to go from a linear equation to a graph without having to fill out a table, but for right now we're going to always be filling out a table. And when you're filling out a table, you're going to choose points. I like 0, 1, and 2. Sometimes if I'm not sure what my line is going to look like, or if it's linear, I'll use like a -1, and that'll usually help me out. But 0, 1, and 2 is where I start. So if I put 0 in for x, 2 times 0 is 0. If I put 1 in for x, 2 times 1 is 2. And if I put 2 in for x, 2 times 2 is 4. Okay, and you can see from here, one of the important things we're looking at is our change in y. Or, sorry, our change in our values. Okay, so x increases by 1 from 0 to 1, and it increases by 1 from 1 to 2. Similarly, y increases by 2 from 0 to 2, and it increases by 2 from 2 to 4. Okay, my change is consistent. All right, and this is where I can find the slope. So my slope is, well, my y over my change in y over my change in x. So my slope here would be 2 over 1. Okay. Now I can use these points to graph my line. So I've got a point at 0, 0. I've got a point at 1, 2. I've got a point at 2, 4. Okay? And if I kept going, I could in both directions forever. All right? My line will be infinite. But the idea is it'll always increase by 1, okay, in the horizontal direction, and 2 vertically, or 2 vertically and 1 horizontally. Okay, so it'll kind of just keep that same step, and it'll go negative, right? Negative 1, negative 2, negative 1, negative 2, negative 1, negative 2. And so I can pretty much create this line just by using my slope. Okay, and if I want, I could draw in my line to connect all the dots, and that is my linear equation in 3 different ways. Okay, as a equation, as a table, and as a graph. All right, to know whether it's linear or not, if your graph makes a straight line, it's linear. If you have a consistent increase, right, I have for every 1, my x increases, my y increases 2, this increases 1, this increases 2. If those are consistent, then it's linear. All right, and then there's some things you can look at in the equation that'll help you determine if it's linear or not. All right, I'm going to go ahead and skip this one, I think, and we're going to look at this one. So x squared is the same as x times x. All right, so if I build my table from that, I've got 0 when x is 0, y is 0. When x is 1, x times x, y is 1. So it's good so far, seems linear. All right, when x is 2, 2 times 2 is 4. Well, now I'm not so sure. If x is 3, I better go ahead and do 3. 3 times 3 is 9. This is looking less linear. Let's go ahead and back and go try negative 1. Negative 1 times a negative 1 is a positive 1. So now I know this isn't linear, right? I definitely don't have a consistent increase. I increased 1 for all 4 of those, but here I increased by 1. Here I increased by 3, and here I increased by 5. Okay, so that's definitely not linear. And if I graphed it, I'd be at 0, 0, I'd be at 1, 1, I'd also be at negative 1, 1, I'd be at 2, 4, and 3, 9. So it looks like my graph would come down, and it might even come back up, and it would be a curve. Okay, so this is not linear. This shows me it's not linear, and the fact that I have an exponent here also tells me that this is not going to be a linear equation. Okay, an exponent, if I'm dividing by a variable, so like this, won't be a linear equation. If I have my variable as like the square root of a variable, that's not going to be linear. Okay, none of these examples are going to be linear. If I had like y times x equals a number, that's not going to be linear. So when you're looking at these, you can sometimes look at the equation, and if you see any of these situations, you can immediately tell, oh, that's not a linear equation. Okay, if you're not sure, you can always make a table. Okay, make a table, check to see if you see that these are not consistent, then it's not going to be a linear equation.